fine. There's example 2. Okay. So here we have Clara and 3 friends. Oh, they were all born on March 11th. Go figure. And Leslie is 5 years younger than Clara. Mike is 2 years younger than Clara. Thomas is 3 years older than Clara. And instead of knowing how old Clara is, you just happen to know that the product of their ages is 61,136 times greater than the sum of their ages. This is very realistic, right? This is what you would normally know in life. And the question is, how old is Clara? Well, the answer is ask her. And if she doesn't tell you, ask Leslie. And then ask Mike. Someone's going to tell you how old they are, and then you're done the question. But no, this is an example of a textbook trying to make a question so that you can practice skills, which is a good thing. You need to practice your skills. But it is not very realistic as far as a word problem. The only thing good that this word problem does is it gives you a chance to practice reading and taking something and see if you can change it to an equation, which is a good skill, but usually you like that skill if it means something for you. I don't think this is very meaningful. However, so if we're developing skills, one of the things you would do is you would pick a variable to represent something. In this case, I think everything is compared to Clara, so let's make her X years old. Then you can compare everybody else. Like, how old is Leslie? 5 years younger, so I would do X minus 5. Mike? 2 years younger, X minus 2. And Thomas? 3 years older, X plus 3. So this is a good skill to be able to read a question, determine what you're going to make your variable, and then write everything in terms of that variable. Now we need to make an equation in order to solve. The product of their ages was 61,000 greater than their sum. I'm going to start this out in words. I'm going to put an equation. We are relating a product, put that in brackets, and a sum. One of them is bigger. Which one is bigger? The product or the sum? Read the question. The product was greater than the sum. This side is bigger. So where am I going to put the 61,136 to make them equal? I would have to add it on this side or subtract it on that side. So again, right now I'm just using words to get a big picture. Because sometimes if you jump into the algebra too soon, you start confusing yourself, like too many x's, and then you get lost. Okay, so now I've got it like this. What is a product? Product means multiply. So this side would be x times x minus 5 times x minus 2 times x plus 3. This side, sum, means add them all up. I'm going to just do some mental math. All the x's would be 4x, all the numbers minus 4. And we get an equation. What we're going to do, and again, I'm going to solve this with Desmos, and I'll solve it with a graphing calculator. The easiest thing I can say to solve this is actually to use two equations. We're going to put this into one equation, and this side into a second equation. And we're going to look, if you have two equations, do they ever cross? All right, so I'm going to go to y equals. I'm going to clear this out. I'm going to do x times x minus 5 times x minus 2 times x plus 3. And on the other side, you could combine your like terms there if you wanted. 4x plus 61132. If I put the minus 4 and the 61,136 together. You don't have to though. You could get the calculator to just have the minus 4 plus, and it will figure it out. Okay? Now I'm going to assume that I had my regular window on and I went to solve this and I see this. I see a blue graph. That's the blue one. Where is my red graph? Nowhere to be seen. I have to find out where these two intersect, but I don't see my red graph. Do I recognize my red graph as something I know? It's a line, y equals mx plus b. Do you see that your b value is 61,132? And you have a positive slope? Okay? So, I'm going to go to my window. I need to see at least 61,132. Maybe I'll go up to 70,000. Do I see my red graph? Yes. Do I see my blue graph? Yes. Do they intersect on my screen? No. Okay. Looks like they'll intersect to the left and to the right. Why shouldn't I look to my left? Right? I'm pretty sure Clara isn't like, what would that be? Pre-born? Negative years old? No, I don't think that's possible. Okay? So I'm going to go to my window, and I'm going to change my x value. I'm not going to put 1,000 in here. I'm going to assume this question is somewhat realistic. Pretty sure Clara's not 1,000 years old. Check up to 100, see if that's enough. Oh, perfect. Now my two graphs intersect. So I want to set my window up so I can see the two graphs intersect, and then I can second calculate. Number 5 is intersect. Enter on the first curve, push enter. Enter on the second curve. It automatically switches from one to the next. Push enter. Yes, push enter again. And it finds it at 17. So we figured out. And what was x again? X stood for Clara. She's 17. Leslie's 12. Mike is 15. Thomas is 20. I'd go with Mike. Mike would tell you how old he is. Save you so much effort in solving all this. But, I mean, it's good for learning some technology. It's good for setting up an equation. Is it a realistic problem anyone would ever solve? No. Like, how would it be possible that you don't know how old they are, but you have this magic 61,136 in your head? Very unlikely. Now, same thing on Desmos. Type in my equation. That's not what I wanted. X minus 2, x minus 5, x plus 3. There we go. And equation number 2, so if I push enter, it goes to equation number 2. Y equals 4x plus 61132. And on Desmos, you can just sort of like scroll out until you can see both graphs. A little bit more friendly to work with. Then if you click on one of your graphs, it'll be like, show you all the important things you might want. Oh, I probably want that point where they intersect, and there's their 17. Kind of nice that way. Bad thing about Desmos is you need a phone or a computer to run it. And those are generally not allowed on quizzes, tests, or exams. So, yeah.